In today's Private Pilot Ground Lesson 1.8, we're going to talk about airplane stability. You will need to know this information for your check ride and your FAA written exam. Stability is an aircraft's ability to maintain a desired flight path with minimal pilot input, and to return to its original flight path after its flight path has been disturbed. For example, if you're flying and your airplane gets pushed by turbulence so that the nose pitches up, a stable airplane would have a tendency to pitch back down and return to its original flight path. Some airplanes are designed to be more stable, such as training airplanes, and some are less stable in order to be more maneuverable. Stability relates to the three axes we spoke about in our lesson 1.1: longitudinal axis, lateral axis, and vertical axis. Stability can be described as either positive, negative, or neutral. There are two types of stability that affect these axes: static stability and dynamic stability. Static stability is the initial tendency of the aircraft when its position has been disturbed. Think about it like this. What is your airplane's immediate response after you make an input on the controls, or after something like a gust of wind has disturbed the position of the airplane about one of the axes? Let's say we're flying an aircraft, we hit some turbulence, and the nose pitches up. Immediately after that happens, the nose lowers and returns to its original attitude. That's an example of what is called positive static stability. If we put our airplane into a turn, then we release the controls and the aircraft responds by remaining in that turn but neither rolls out or gets steeper. That's an example of neutral static stability, which is the tendency to remain at the new position. If now we roll our aircraft to a high bank angle, we let go of the controls and this results in the aircraft continuing to roll further. This is an example of negative static stability, which is the aircraft's tendency to continue away from the original position. Now let's talk about dynamic stability, which is the response of the aircraft over time when there has been an upset to its original position. If our airplane is set up for level flight and we pull back on the control yoke, when we release it, the nose will promptly begin to lower. The degree of nose down pitch will depend on the initial control input. Eventually, the nose will gradually rise again, but not as much as the initial input. After a while, the pitching motion will cease, and the airplane will return to its original position. This is an example of positive dynamic stability, which is characterized by oscillations that diminish over time, allowing the aircraft to regain its equilibrium. Aircraft with neutral dynamic stability exhibit perpetual oscillations that do not diminish over time. When a neutrally stable aircraft is pitched up from its trim position, it will initially pitch nose down, then return to a nose high attitude, and these oscillations will persist indefinitely in theory. Aircraft with negative dynamic stability experience increasing oscillations as time progresses. The pitch oscillations gradually increase in magnitude, becoming more pronounced and amplified over time. Longitudinal stability is the characteristic that makes an airplane stable about its lateral axis. Longitudinal stability ensures that the aircraft naturally returns to its trimmed attitude after disturbances, such as gusts or control inputs. The longitudinal stability of an airplane is influenced by the position of the center of gravity relative to the center of pressure. For longitudinal stability, it is important to have the CG located ahead of the CP. This configuration ensures that when the aircraft experiences a disturbance, such as a gust of wind or a control input, the nose of the aircraft tends to pitch down, causing a restorative force that helps the aircraft return to its original attitude. When the CG is located at or rear of the aft CG limit, the airplane develops an inability to recover from stall conditions, becomes less stable, and has an increased likelihood of inadvertent overstress. Lateral stability is the tendency of an aircraft to resist roll. It ensures that the aircraft remains level and maintains its desired bank angle during turns. There are four main design factors which make an airplane stable laterally: dihedral, keel effect, swept back, and weight distribution. I hope today's lesson was helpful. If so, please like, subscribe, and hit the notification bell so you don't miss out on any future private pilot ground school lessons. And if you're interested in doing your private pilot ground school online directly with me and have me sign you off to take your FAA private pilot written exam, please reach out at chickswhoflyofficial@gmail.com.